At this hub then here. So what's the strategy in limiting reagent?
Find from each reactant, find the grams of CO2.
Okay, yeah, since we're going to do, not, in this case, we're going to do the theoretical yield of CO2 in liters here, since it's a gas. We'll just do that. And so we're going to find the yield of each, so let's calculate the yield of CO2 from the glucose first. So to do the yield of CO2 from glucose, then we're going to start off with 5.15 grams of glucose. C6H12O6. Then we're going to get the molar mass. So did you calculate the molar mass? Somebody calculate the molar mass? No?
180.18.
180.18 grams per mole. So grams, so we do gram to mole conversion. Now we got moles of glucose. From moles of glucose, we're going to go to moles of carbon dioxide. So it says 6 moles of carbon dioxide for every 1 mole of glucose. Okay, now we have to make an assumption, or we have to be given some additional information. If we go to grams, then no problem. You know, it doesn't matter. If we want to go to liters, then it matters. You know, for liters, we need to know the pressure and the temperature. And so what we can do is we can just go ahead and make the assumption that we're dealing at what temperature? What do you think is a more common temperature? Standard temperature or room temperature? Room temperature and pressure would be 1 atm. Now, if we're dealing with that, then a pretty useful one to remember is that we have 24.45 liters for every mole. You know? Now, if we change the temperature and pressure, that's going to change the molar volume, and so we'll do that. If we do grams, then it doesn't matter. You know, the grams are going to stay fixed regardless of the temperature and pressure. But since this is a gas, let's go straight to liters. Let's figure out how many liters of CO2 I'm going to generate. So 5.15 divided by 180.18 times 6 times 24.45. I'm going to generate 4.193 liters of CO2 gas. 4.193. That would just be pure CO2. Okay, after I calculate the yield of CO2 from glucose, where do I go next? Yeah, this is assuming that I have plenty of air to burn all the glucose. And so I'm going to repeat the same calculation. I'm going to do the yield of CO2 from air. Okay, this is assuming I have plenty of glucose to react with all the air. Let's go ahead and react all the air and see how much CO2 is produced. So in this case, I'm going to start off with 15.0 liters of air. And then this equation is not for air, this equation is for pure O2. So I'm going to figure out how many liters of pure O2 I have, and that's given over there. I have 20.946 liters of pure O2 for every 100 liters of air. So liters of air cancel, that tells me how many liters of O2 I have. And then from liters of, O2 is a gas. So since O2 is a gas, then we can go from liters of O2 to
Carbon dioxide.
yeah. we can do two things. We can go from liters of O2 straight to liters of CO2, using Avogadro's, or we can go from liters of O2 to, not to grams, but straight to moles of O2. So there are two ways of doing this. So here, the long way, we'll go from liters to moles. And so there are 24.45 liters of gas for every mole of gas under these conditions. Any gas, it can be air, it can be O2, it can be CO2. And so that will take me to moles of O2. And then from moles of O2, I'll go to moles of CO2. So there are 6 moles of CO2 for every 6 moles of O2. And so the moles of O2 cancel. That leaves me with moles of CO2. And then moles of CO2, they're going to be 24.45 liters of CO2 for every mole of CO2. So moles of CO2, and then I end up with liters of CO2. This is a long way. The quick way is just to do a liter to liter conversion. And so for every liter of O2, I need the same, or I produce the same in CO2. And so you can see that here. The 6 cancels, the 24.45 cancel, and so the number of liters of O2 will be the same as the number of liters of CO2. This is a 1-to-1. So if this is 6 moles to 6 moles, or 6 liters to 6 liters. It's a 1-to-1. Mole ratio, it's a 1-to-1 volume ratio as long as the pressure and temperature are the same. And so let's go ahead and calculate it. It's going to be 15 times 20.946 divided by 100. And it gives me 3.141 liters of CO2. Okay, so what would be my theoretical yield of CO2? If I try to burn my 5.15 grams of glucose in 15 liters of air, how much CO2 will I produce? 3.14. So the smaller amount is my theoretical yield. And so what this tells me is that my limiting reagent is what? The air. I don't have enough air. This is my limiting reagent. And so once I've used up all the oxygen in the air, there's no more oxygen to combust. There's going to be some leftover glucose. And so the glucose is my excess reagent here. This is excess. And so I didn't put enough air. I was trying to save air by putting 15 liters. I should have put in some more. I didn't put enough in. And in fact, it looks like I burnt about 3/4 of it, or maybe 6/10, something like that. So what should I do? Well, I need to add more air, but I don't have more air. It's gone. What I need to do is I need to figure out how much glucose remains. And so can you do that calculation for me? Can you calculate the excess glucose that remains unreacted? In other words, the excess glucose remaining. And so how many more grams of glucose do we need to combust? Or how many grams of glucose are left over? So can you go ahead and do that calculation? And I'll